All right, let's dive right into this explainer on cracking the modern software development engineer and test, or SDET interview. Look, if you're a QA engineer or an automation tester really looking to level up, you are exactly in the right place. We're not just going to sit here and memorize textbook definitions today. That doesn't work anymore. Instead, we are going to look at exactly how experienced SDETs approach live problem-solving scenarios, how they design resilient framework architectures, and how you can completely bypass those common traps that instantly eliminate unprepared candidates. So you might be wondering, what are interviewers actually looking for these days? You might think it's just about writing test scripts, but there is a massive difference between a junior tester and a senior automation engineer. You see, freshers, they just memorize what specific tools do. Senior SDTs, on the other hand, well, they know exactly how to defend their architectural choices when those tools inevitably fail in a live production environment. Senior engineering teams aren't just looking for someone who knows the syntax, they are actively evaluating your live problem-solving skills. They really want to know, can you analyze raw requirements, define a practical real-world testing strategy, and build a completely robust framework from absolute scratch? Here is our quick roadmap for today. First, we'll cover the perfect SDET stack. Second, mastering frameworks and tools. And third, acing those essential JavaScript interviews. Okay, kicking things off with Section 1, the perfect SDET stack, and building our roadmap. Think of this like building a house. You cannot build a solid house without a foundation, right? It all starts with core programming, JavaScript and TypeScript fundamentals. If you try to jump straight into Playwright without mastering TypeScript first, I guarantee your framework will be brittle and prone to flaking out in production. Once you have that foundation, you move to the actual automation tools, specifically mastering Playwright for both UI and REST API automation. Step 3 is all about execution, deploying those tests using CI/CD pipelines and Docker infrastructure. And finally, Step 4 involves supercharging that entire workflow with AI coding assistance. Interviewers want to see that you understand this entire vertical progression, not just isolated testing tools. Now here's a massive trap I see candidates fall into all the time during architecture rounds: mixing up their infrastructure concepts. Junior candidates will frequently conflate where we host our servers, cloud services like AWS or Google Cloud, with the DevOps tools we use to actually maintain and scale our test deployments, like Jenkins or Docker. A senior candidate, however, draws this distinction perfectly on a whiteboard. If an interviewer asks you to design a continuous integration pipeline, you need to clearly articulate that you're going to use a DevOps tool like GitHub Actions to execute your automated tests, which might independently be running over on an AWS cloud instance. Nailing this difference shows serious technical maturity. And when we hit the top of our stack, remember this: AI tools aren't replacing you. Utilizing tools like GitHub Copilot acts as anti-gravity. It literally lifts the heavy coding burden off your shoulders. For example, a senior SDT is going to use Copilot to generate massive amounts of boilerplate page object model classes in seconds. This saves all their mental energy and brain power for what actually matters: advanced test strategy, handling really complex asynchronous edge cases, and live problem solving. You leverage AI to move faster, not to think for you. Moving right along to Section 2, mastering frameworks and tools, focusing on actual project realities. Okay, picture this. You're in the hot seat, and the interviewer slides a laptop over to you and says, "Initialize a new project." When you install your tools, where exactly does Playwright go? It's a dev dependency. Why? Because you absolutely need it to build and test the software in your local or CI environment, but, and this is key, it does not ship with the final production product to the end user. Explaining this strict distinction shows you understand the entire software development lifecycle. It proves you won't accidentally bloat a production build with a bunch of unnecessary testing libraries. Interviewers absolutely love e-commerce scenarios because they immediately expose exactly how you think. Let's say you're asked, how would you automate the Amazon checkout process? A junior tester is simply going to talk about automating the UI, finding that add to cart button and clicking it. But the interviewer wants a deeper strategy. A senior SDET will explain how they'd validate the REST API token for the user session right behind the scenes. They'll talk about querying the database to ensure the backend inventory actually discriminated, and crucially, they're going to focus on test data creation. How are you generating mock credit card data dynamically on the fly so your tests can run in parallel without colliding? That holistic end-to-end thinking, that is exactly what gets you the job offer. Let's pivot to our third and final section: ace essential JS interviews and avoiding the fundamentals trap. First things first, completely scrub the legacy var keyword from your vocabulary. Modern STTs use let for variables that will change and const for absolute constants. If an interviewer watches you write a framework and you use let for a base URL that should literally never change, you instantly lose points. Using const prevents those accidental reassignments that introduce incredibly hard-to-find bugs into your test logic. Now, here's a classic follow-up trick question to watch out for. They'll ask if a const array or object can be modified. The answer is yes. The reference is constant, but the contents inside that array can absolutely still be mutated. Knowing that nuance really separates the novices from the architects. Okay, this next one is a classic interview trap you must memorize, and it applies directly to real QA scenarios. Undefined means the JavaScript engine just doesn't know the value yet. Null, on the other hand, is the programmer explicitly stating, hey, I am setting this container to intentionally have no value. So, if your API test fails and returns undefined, it likely means your payload didn't even grab the data properly from the response. But if it returns null, it means the database explicitly sent back an empty field. Knowing this difference during a live coding challenge proves you can accurately diagnose network requests, and it's going to save you hours of debugging in the real world. Oh, and here's a super fun piece of nerdy trivia that interviewers just love to throw at you to see how deep your JavaScript knowledge really goes. If you run a type of check on null, JavaScript returns the word object. No joke. This is a famous, completely unfixable bug built into the core language itself from its earliest days. Casually dropping this fact in an interview shows you've spent real time in the trenches fighting with JavaScript's unique quirks. I'd honestly recommend taking a mental snapshot of this matrix. If you want to separate yourself from the pack, you have to understand memory allocation. Proving you know that primitive types go directly to the stack memory as direct values, while non-primitives use the heap memory to store reference addresses is a massive advantage. When you're passing huge JSON payloads in your API tests, knowing that non-primitives use heap memory by reference dictates exactly how you structure your test data. It ensures you don't accidentally overwrite global variables across different test files that are running in parallel. When you're asked to write assertions for your tests, please remember this. Double equals is dangerous. It tries to helpfully convert data types to match, which sounds nice, but let's look at a real-world example. If your e-commerce cart expects the exact integer 5, but the UI returns the string 5, double equals will pass the test anyway. This completely masks a potential critical UI bug in your application. Always use triple equals, which strictly enforces that both the value and the exact data type are identical. Senior SDETs demand strict comparison for absolute testability. Finally, your programming mindset is definitely going to get tested on execution flow during live whiteboarding. Listen carefully to this logic puzzle. JavaScript reads your conditions line by line, right? And it completely stops at the very first true condition it hits. So if you casually place a lower threshold, like greater than 50, before a higher threshold, like greater than 60, a test score of 70 will trigger that first greater than 50 block. It will then exit the loop entirely and ignore the rest of your code, completely destroying your test logic. The meticulous sequence and order of your reasoning is exactly what interviewers are paying very close attention to. So I want to leave you with this provocative question to ponder. Anyone can copy and paste a test script from a tutorial, right? But understanding the why behind the code, why you chose that specific memory structure, why you configured those dev dependencies exactly like that, and why your execution flow is ordered perfectly, that is the real key here. Being able to successfully defend those decisions is what truly transforms you from a novice tester into a highly sought-after senior automation engineer. Keep practicing those live problem-solving scenarios, and you are absolutely going to crush your next interview.